activated.
Hello again. I am your AI co-host, and welcome to 3.8. 3.8 is a podcast focused on the process of doing and the process of novel invention, all from the foundation of creativity. Today, we're speaking with Dmitri Kalashnikov. Dimitri is a climate scientist and National Science Foundation postdoctoral research fellow at the University of California, Merced. Having created convolutional neural network-based predictive models for lightning in the western United States, he is currently working on applying these predictive models to climate models to project future changes in the climatology of lightning storms in the western United States, along with the risk of lightning-caused wildfire ignition, which is approximately the cause of 70% of wildfires. Oh, wow. The humans discuss Dimitri's journey into a Ph.D., climate change as a dynamic system, the challenges of communicating climate science, bomb cyclones, and the impossibility of humans creating or steering hurricanes. You can support this podcast at patreon.com/38 or at ko-fi.com/38. Each month will bring you no more than 5 episodes through the lens of art, science, and or technology. And now the humans.
Today we're in studio with Dimitri. Dimitri, where does this podcast find you?
Hi, Andrew. Thanks a lot for having me on the podcast. So I am currently a postdoctoral research scientist at the University of California, Merced, but I am remote, so I still live in Portland, where I'm from, and get to do my job from home, which is nice. And I just finished a Ph.D. this past spring at Washington State University, Vancouver, which is also here in the Portland metro area.
Congrats.
Thank you.
A lot of people probably have no idea what completing a Ph.D. is or doing a Ph.D. or what's entitled with all that process. So can you just take people through, especially in the sciences Ph.D., it's probably a lot more work than people realize. So I guess, how did you decide to get into it? But then what was your journey like and how long did it take?
Yes, indeed. That's a loaded question, but I have answers. So a PhD is definitely a journey. It takes typically in the sciences 4 to 5 years. I finished mine in 4 years, which was a little on the short side, actually. Yeah, it's a process. You learn a lot of things, and you're expected to be good in a number of different areas. So it's not just the science aspect. You have to be a good writer. You have to be a good programmer. We write our own code, a lot of analysis code, essentially. I use Python, for example, for my analysis. You have to learn how to be a good presenter in terms of public presentations at conferences or sometimes to sort of layman audiences. If you are a TA or a teacher's assistant, you have to learn how to teach too. Instruct and advise students, essentially. So it's a lot of skills that you have to develop in that 4 to 5 year window. And as far as my journey, I'm a little on the older side. I'm actually 41 this year.
Wow. Congrats. You made it 41 years.
Yeah, exactly. Yes. So I definitely have a bit of a late start to my journey. But that was kind of how my path developed. I basically finished my first bachelor's at 21. And then spent a good decade working other jobs where I wasn't in the sciences. I tried a couple different careers. One was in actually like logistics/distribution. One was in sales. Did some years in sales, making income to pay the rent, et cetera, et cetera. But then in my early 30s, I got the itch to do something more. And my passion always was the natural world. So climate, weather, geography, environment, animals, everything to do with nature, essentially. And especially climate and weather. And so I wanted to go back and really focus on that. So I went to Portland State University, got a second bachelor's, got a master's degree.
Oh, so you basically restarted the whole cycle.
Essentially,
Wow.
Yeah. Which made sense for me, you know. But yeah, I got my master's in climate science, where I basically started my career as a researcher in the climate space.
Yeah.
And that was 5-6 years ago now. I basically finished that and went on to WSU to do the PhD. And that kind of set my current career track in motion.
That's awesome, man. Like I didn't realize that you kind of started over, especially like, so going to college post like 18 is kind of rare already. And so not only did you kind of do college and then you went back and then you just started the whole track over again. It's like most people when we finish a PhD are probably what, mid-20s?
Yeah, I would say late 20s to early 30s these days. Yeah.
And then you typically do like a postdoc too, right? Or more, or maybe you do 2 or 3 postdocs depending upon your field. And so that's basically working for free, right? I think people also have this assumption that PhDs make all this money, and it's like some of them do, but it's very, very low pay field for some people.
To be fair, though, just to clarify, postdocs do make a living wage.
Yeah.
So, PhD students are perpetually broke.
Yeah.
A graduate student stipend is not a lot of money.
Right.
But yes, at a postdoc level, you actually are considered like a full-time professional, essentially.
Yep.
So you get a living wage, but it is woefully below what you would get in industry. Right. They're not sort of broadly competitive wages.
In industry is what the rest of us just call jobs, right?
Regular jobs, not in academia. Yes, right. That's, I guess, a bit of jargon.
Yeah. No, I'll try to de-jargon. I've worked a lot in academia, so I'll try to de-jargon as we go, because I think I think a lot of people have this Hollywood, mindset of a person in a white coat with like beakers and glass and shit, and then long nights, and they're sleeping under the bench, and then there's this like aha moment, and they create, the fucking physics or something, and then the whole world changes, and that does happen, but it's usually a pretty long road. And I think a lot of people would be surprised to see how mundane a lot of the work is. It's like interesting work for people who are doing it, but it's just like every other job, right? You show up and you do a bunch of stuff and then you get some sort of an output.
Absolutely. Yeah, absolutely. Like the old joke in data science, how you spend 80% of your time on cleaning data,
formatting, and getting the commas out, and
it's very similar.
So you're pretty like new to the field, but yet you're not very new to life, and I feel like that puts you in a really interesting position. I know, like when I was going through school, had I known what I know now, that kind of hindsight thing. When I was in my undergrad, I had a lot of friends who were also non-traditional students. Like a non-traditional student, I think, is somebody who technically starts in their 20s.
Yeah, anytime after the usual track.
They take a couple of years off, or maybe they went to like a tech school or something, and they're coming in and starting over or starting something else. But I found that a lot of them had a better perspective, I think, on the whole thing, because they've had extra life experience. And part of that, I think, is just like a time thing, but also it's interesting too that you did other stuff, because I think for a lot of people, at least a lot of people I know in research or in academia, they either from a young age had this like burning passion, and so they were always doing biology stuff, and even in like elementary school they're like counting fish and shit, and then it's like you're kind of like, oh, that's obvious, right? Or they become a medical doctor because they're fascinated with that kind of thing. And so I think you like check 2 boxes for me in like kind of the untraditional world. And I'm interested if you have any observations on how, you think your journey might have been different given that experience going in. And like you said, you finished, I think, in about 4 years, which is also unusual.
Yeah.
Do you think that having like life perspective outside of that and then choosing really your focus helped, or was it more of just like you wanted to get done and get on to the next chapter?
Yeah, I think it's the first thing you said. I think having the life experience really, really helped me in a couple of ways. One is just self-confidence. Having been out there, living life, working jobs, it's very different when you face, for example, a stressful school situation in your 30s with that life experience versus when you're 22, let's say. And just the perspective too, when things got difficult during my master's, my PhD, I just had to remind myself, what? This is just a job.
Right.
Kind of walk yourself back from thinking, oh, this is a PhD. This is going to be huge. Well, it is. But, in daily life, you can walk it back a little bit and remind yourself, what? I'm doing my job. It might not be fun today. It might not be stressful, but this is my job and I'll do it today.
Yeah.
And that comes from having done full-time work for years, right? Which a younger, less experienced grad student might not have that perspective. They might get stressed out and overwhelmed, So I think that's a pretty key difference. And the other thing I think that I had going for me was just the punctuality and discipline in terms of I need to put in the hours to get my research done versus maybe being tempted to take time off. It's a very flexible schedule. Grad student.
You need a lot of discipline. Yeah,
you do. Yeah.
And it's so fun. I 100% agree with everything you just said. So I did my bachelor's, I think, on the normal schedule, and then I did a master's a while after. I don't do time very well. I'm just kind of like, I don't know what happened. But it was like actually pretty recently. So it probably would have been at least 10 years maybe out of, and I had done work, all sorts of crazy stuff across the country. And going through my master's was way easier because I always heard like how hard masters were, and like, yeah, it's hard in that you have to like produce knowledge. Sure. There's a lot of information you have to learn. But that's no different than the corporate world that I was in. I'm constantly meeting with people. I'm trying to pitch people. I have to present to different audiences, and being able to kind of understand and synthesize that. Like, I guess they call them soft skills now too, a little bit. Yeah. Having those soft skills, or some people might call it like maturity.
Sure.
I blew through my master's, right? In like record speed. And there's never enough time. There's no secret information. Like, imposter syndrome is what everybody has. Even the most successful people don't think they're doing well.
Sure.
If I interviewed Taylor Swift, I'm sure she'd be like, oh, here's a list of 50,000 things I don't do well that I'm trying to get better on, right? But she's clearly at the top of her game. Like, is it teachable? So like, creativity is an example I use a lot, where a lot of people perceive it as something you're born with, some ability.
Sure.
But it's really just a process, right? It's getting stuck, it's getting unstuck. It's very similar to science in that you're trying a bunch of stuff. If you are aware of what you're doing, you'll make something different. Writing a song and creating new knowledge isn't that different if you're creating a new song. The process is really similar.
Sure.
So I know I'm like rambling now, but do you think those kind of skills that you picked up on that made you successful later in life through a PhD are something you can teach and train, or is it just something that you just have to go through in life and then you get it?
Yeah, so it's a good question. I think to some extent you can teach these things, but not fully.
Sure.
I think a big component of that is just lived experience, which is impossible to replicate, I think. Another thing about that I didn't really touch on, I think when it comes to grad school, and especially when it comes to a PhD, I really believe that what you're doing should strongly align with what you truly are passionate about.
Yep.
Maybe a master's you could get away with doing just because you want a better job. But for a PhD, if you're going to have that 5-year sort of intellectual, emotional, life-changing commitment to that field of study, it has to be something you're naturally inclined toward and naturally strong at. So in my case, I loved weather and climate. Just like as a kid, I used to check the weather forecast, to check what the record high, record low were. It was deeply interesting to me. So it was a natural fit to then study that for 5 years.
Right.
I would not want to if I wasn't already inclined that way. Or maybe I would, but I wouldn't be as good. It'd be a harder uphill sort of
you didn't go to get your PhD in logistics operations or something, right? Or like business. I guess there are technically PhDs in business, but they're a fucking joke. As a person with an MBA, I can say that. People fucking hate comments, but whatever. But I think that's like the big problem in business, right? Is they're trying to teach you all of these lessons from CEOs or executives or people who have been very successful. And it's really easy to read a book and be like, oh yeah, I could make Uber too. You could, but you didn't. And, a lot of other people were trying and they failed. And for some reason, we don't write books about I fucked up massively and lost all my money and now I have to go work at Apple, right? And like, to some extent, I wish we would write more of those because it's like, there's like this air of celebrity, I feel like, in the culture that's permeated in business and even academia, where it's like everybody's looking for the next Einstein. But the reality is like Einstein was just like the person who amalgamated, probably dozens, if not hundreds of people's work over a couple lifetimes. Not to try to detract from like what he did, but at the same time, it's like there is no one single point of genius that produces the next thing. A person will do that, but you have to build on it, right? And I feel like, especially in the climate space, from what I know, it's like we know a lot about it, but yet we almost know nothing. Or as we're learning such new information that it's really disrupting our previous knowledge. Is that accurate in your mind? Or I know that's like a super overly generalized statement.
I would say it's okay. I would say there's a lot of truth to what you're saying, and you're clearly a very informed person. So, I think climate is a field where there aren't a lot of very groundbreaking discoveries in terms of, we understand the general physics and mathematics and the sort of governing equations of how the atmosphere behaves. That stuff was worked out a long, long time ago. We're talking decades, out to a century ago. The progress that's being made and has been made is more about understanding that system better.
Sure.
The physics we know, it's how it interacts across scales, how it evolves, how things connect is really what we're still learning a lot about. And that's extra challenging because the climate is changing.
Right.
So it's not only a dynamic system, a nonlinear dynamic system, it's also a non-stationary in time system. It's changing. The climate patterns you see now are maybe acting differently from 10 years ago because the climate has changed in the past 10 years. So that makes things even more challenging. But there's progress, incremental progress being made with every study. Every year, there's progress being made in trying to understand little slices of that system better.
I'm going to try to break that down into an analogy. So I think like an analogy could be your refrigerator at home. We understand how that works. Well, maybe not everybody does, but it's pretty well served, right? It's a insulated box and there's a compressor that cools air and then it cools down the stuff inside. And if the door's shut, it maintains a relative temperature. There's ways to kind of change that with thermostat and whatnot. But if it's empty, you can understand that it just cools the box down. But if you're trying to understand how it cools and you're constantly opening and closing the door, putting in the milk and the groceries, taking out the groceries. Now you don't know really how much is in there. It's like it's constantly changing, but you're like, well, it holds food. Well, how much food does it hold? Well, I don't know, 6, bananas and a milk. Oh, now there's 5 bananas and no milk and it's orange juice. So is that like, I don't want to confuse people, but I think like understanding like a nonlinear dynamic environment is also something that it's really hard to talk through without math or visuals. But the idea is that we understand the basic how it works. So we understand the refrigerator and it cools stuff, but by opening the door all the time, it doesn't cool stuff. And as the climate is changing, it's impossible to really, I don't know if it's impossible. It's very difficult to try to understand a system that you're trying to measure that's in change. And I don't know, I guess how else to put it. And that's as like basic as I can make it for folks. Sorry.
Yeah, not a bad analogy. And if I can maybe, elaborate on what I said, because I realized, it's not everyone's cup of tea to think about dynamical systems and nonlinearity and all that.
Coming from AI, I'm used to it, but
sure, right, exactly. But I guess to break it down a little more, the Earth system is largely water, right? It's 70% oceans. And you have the atmosphere, which is constantly in motion. It's a 3-dimensional sort of layer of air that's always moving, always swirling. Yeah. And it's interacting with the ocean because the ocean sort of gives off its own heat.
Sure.
And
and the ocean's also allegedly water, right?
Yes, indeed. Yes, indeed.
So there's water. I guess maybe I'm being a little sarcastic, but the atmosphere is also full of water, right? There's a lot of
water vapor.
Right? And then the ocean obviously is wet water. There's states of matter, right? You have gas, liquid water, plasma.
Exactly.
Solid.
Exactly. And the atmosphere actually behaves like a fluid. The equations that sort of describe how the atmosphere behaves are fluid motion equations. Mm-hmm. So think of it as essentially a fluid, right? But it's exchanging energy with the ocean. So the atmosphere exchanges energy with the ocean at all times. It's a two-way exchange. So if the ocean warms up, so imagine the Pacific Ocean, the largest body of water on the planet. If you have an area of the Pacific Ocean, let's say off the coast of Japan that has above normal sea surface temperatures. Right. So the ocean is warmer than average, right? That is going to affect how much energy, the warmer the water, the more energy it gives off, how much heat energy and how much water vapor.
That's why you get burned from steam, right?
There's more energy and more water vapor. So that gives off more in that particular part of the Pacific Ocean, which then impacts the atmosphere in that particular part, over that particular part of the Pacific Ocean, off the coast of Japan. So that'll actually impact how the jet stream moves over that part of the ocean, and that impacts how the air then moves across the rest of the Pacific.
Right.
So you'll have differences in how weather patterns then happen over Western North America, just based on how above average or below average the sea surface is in different parts of the Pacific and the Atlantic, because it's all connected globally. So that's really, really difficult to disentangle what the actual causal factors are and how it affects prediction for 2 months from now.
And as the cloud sort of I'm going to speak super generally, like forms over Japan and brings that moisture over the Pacific, it's picking up more moisture in the Pacific. It's raining in the Pacific. Things are hotter and colder in other places, right? And so that's all kind of changing the path of this, I guess, cloud. And then it hits, Oregon and we get a bomb cyclone, right? What do they call Pineapple Express? There's all sorts of like colloquial terms for these like super events that just kind of come, but most of that comes out of the Southeast Asia, doesn't it? Like, and then it just atmospheric river. Can you explain that maybe?
Yeah,
I hear that a lot lately.
It's definitely more complicated. And you're right. We've seen this rise the past decade or so of these catchy terms like bomb cyclone, right? Atmospheric river. Polar vortex.
Yeah, polar vortex. That's a good one.
Yes. And these terms, these terms were actually around for decades before this as sort of like jargon in the weather world. But at some point, the media sniffed them out as sort of catchy terms. And now they are
pretty good.
They are pretty good. Yeah, they're pretty good. And now they're common knowledge, right? Yeah. But yeah, in terms of atmospheric rivers, and you mentioned the connection to Southeast Asia, it could be the weather we experience could be connected to many other regions.
Right.
It could be connected to the Eastern Pacific Ocean or the Central Pacific Ocean near Hawaii. Actually, the term Pineapple Express comes from the fact that when we get these really heavy rainstorms in the Pacific Northwest, sometimes the moisture is actually coming from near Hawaii.
Interesting.
You can see on the satellite image this plume, this long area of clouds, thin, sort of narrow. Imagine like a line, or really a plume. That's probably the best word, of clouds and moisture that streams all the way from Hawaii up to Oregon, Washington. It's being carried by the atmospheric winds towards us. So that's actually the origin of the term Pineapple Express.
Got it.
The more modern term is atmospheric river. Yeah. If you hear the term atmospheric river, that's like a general catch-all term for atmospheric moisture transport in these concentrated pathways.
Right. So it's trying to break this stuff down again. So the river analogy, I guess, I think makes a lot of sense to me. When I talk to folks, they get really confused by it because it's like, the Willamette is right next door, or the Columbia, right? You can see it.
Sure.
And it's pretty predictable. But when an atmospheric river comes to town, it's like we don't typically know until a few days before. The atmosphere and the oceans are interacting in water. And like, is it atmospheric river just kind of a higher volume of moisture moving through or moving through swiftly and kind of collecting like a river versus like a mist?
Yeah, maybe a better analogy would be like a hose, like a fire hose. Because really all that an atmospheric river is just this concentrated stream of atmospheric moisture.
Right.
Like if you imagine a garden hose, sort of, I can't.
Flailing around.
Yeah, people can't see visuals. I'm doing hand visuals as if listeners can see them. Yeah, a flailing fire hose or garden hose. Yeah. That's what that is. It's temporary streams of concentrated moisture in the atmosphere.
Right.
And they carry moisture from the tropics northward.
Right. And unlike a land river, they don't have a set path.
There's no set path.
I think that's the disconnect that I get a lot from folks, is that they can kind of appear at random.
Yeah, they form, they break down, they meander. Sometimes they'll sit over one area for 2-3 days, and you'll get a lot of heavy rain, a lot of flooding. that happens sometimes in California, Oregon. In fact, the biggest floods in the history of California, Oregon, Washington were all to do with atmospheric rivers.
Right.
They're multi-day sort of persisting storms that just dump rain.
Yeah. And so because these don't happen every day or they don't happen every month, that's the variability between like climate and weather, right?
That is.
Weather is what we experience and climate is kind of just the system that we're in.
Yeah, it's the average of the weather.
Yeah.
So a good example there would be a single atmospheric river is a single storm. That's
Right.
weather. But if over many years and many decades, due to climate change, the number of atmospheric rivers you see changes.
Right.
Maybe it doubles or maybe it decreases. So that's climate. How many do you see in a given year?
You talked about averages of weather. And I think when it comes to like rainfall or snowfall, because I hear it still snows, global warming, right? I'm glad we got rid of global warming a little bit, but we kind of fucked that one up. Thanks, Gore. So if you look at a yearly average rain total, it doesn't reflect very easily the extremes of the weather, right? So if it rains for an entire month in Oregon and then it doesn't rain for the rest of the 11 months, but it averages out in that our yearly rainfall is roughly what it normally is, I feel like it hides the fact that the extreme weather events, as I guess the media is kind of calling these, or the increased volumes of moisture or lack of moisture doesn't really compute with folks. It's really hard to kind of conceptualize because you remember the flood, but you don't remember the light rain that you had for, all of time.
Sure. That's a great point. That's a great analogy, actually, in terms of, yes, averaged rainfall amounts, whether it's over a year, but even over a month and even over a day sometimes are not reflective of how the rain fell, how intensely, how quickly. And that's why it's so important when you're doing climate studies, you don't just look at the average values. You look at the extremes. So some of the most interesting climate studies to me aren't ones that quantify sort of long-term averages and changes in them. They look at the individual characteristics. For example, will the number of wet storms increase or decrease? Or if you take the top 5% of the wettest storms, will they get more extreme or not? You can quantify all this stuff in climate models. You have daily resolution and sometimes sub-daily, so 6-hourly, 12-hourly. You can look at these things in climate models more precisely than just the average values.
Yeah, because I feel like folks in Oregon too, but elsewhere, I feel like the rain that we get in Oregon, even in I've been here for, 7 or 8 years, but it's become more intense. Like this is totally anecdotal, but when it rains, I feel like we get storms like it used to be in like when I was in the Midwest. It was rain and you got soaked because a ton of water comes out of the sky, and that's pretty normal for there. Oregon, usually it's kind of a lighter rain all day. It might kind of come, medium intensity here and there, but like you walk around in a raincoat. Now I get soaked sometimes.
It's interesting you say that because this, I think, also illustrates sort of the discrepancy sometimes between what we think we see and what the long-term statistics say. Because I agree with you, especially the past couple months. I've noticed we've had a lot of really heavy downpours.
I call them monsoons, even though they're not technically monsoons.
Right. Yeah, they're not. But, I see the analogy. Yes, so I've personally noticed how it seems like we've had a lot of heavy downpours, but that's a blip in time.
Right.
A few months period is a blip in time. Even a 7-8 year period could be considered a blip in time if you look at 100 years. The climate varies over decades, right? Even imagine a long-term trend, but there's variation around that trend. So for a whole decade, you could have an opposite trend just because of how the climate is naturally varying. Now, to get back to the precipitation, the long-term trends for rainfall actually don't show an increase in Western Oregon for daily intensity. So you look at the daily total values, there's actually a decrease in some parts of Western Oregon in the past 60, 80 years. So it's yet to be unpacked why, but there was a paper that was published this past summer, that looked at trends in daily rainfall amounts in the Western U.S. since 1950. So we're talking a good 70, 75 years of data. And their hypothesis as to why we're not seeing an increase in daily rainfall amounts is because there are large scale, and forgive me if I'm getting into like sort of jargon, but essentially the large scale weather patterns that happen are, or at least have changed in such a way that they're not letting extra heavy rain to occur. There's more atmospheric moisture. So we know this fact.
Yep.
With a warmer atmosphere, it can hold more water vapor.
Right.
So all else being equal, a warmer climate will have a warmer atmosphere, which will allow for heavier rain to happen. So when it doesn't happen, like in Western Oregon in the past 70 years, you have to look at why.
Right.
And so they found that the way the large scale, and when I say large scale, I'm talking like 1,000 miles, 2,000. So think high pressure ridges, low pressure troughs.
Yep.
So they've changed in such a way to where they're not letting as much of that atmospheric water vapor to come into our area.
Interesting.
During those storms.
It sounds like a hydrolock. Right? Like I'm not even gonna try that one on the podcast, but that's really interesting.
I hope that made sense.
Yeah. So then the moisture does go somewhere. Right?
It goes elsewhere. So
Right.
rain is increasing elsewhere.
Right.
Yes.
And then during the pandemic, I always reminded people there's no rule that says we can't have two pandemics at the same time. So the rain could also just be falling right back in the ocean, right?
It could be. Absolutely.
We're just not really sure, or people haven't looked maybe even as where, like, that's something I really want to unlock with this, because that's the iteration process of science, right? So we learn that what you just described, and I'm not going to try to summarize it, but then it leads to the next question is why, right? We observed something that happened, and so now we need to look at other information or devise more experiments to try to understand, is that the correct observation? And if it is, list of questions.
Yes.
Right. And I think that's where, I think a really easy example, even though this isn't your field, is like the healthcare. I feel like every other year, like, carrots are good for you. Carrots cause cancer. Carrots will give you a heart attack. Carrots will cure a heart attack. But that's a point in time. It's probably a single paper. It's a single study. That's what the evidence says, or the data suggests. Then people make all sorts of crazy conclusions on that, and most of them probably don't have any business doing that. But then the next part of that process is to then say, why? And then you devise another study, and then you learn something else. And maybe that original paper, maybe carrots, do cause cancer, and we should stop eating them, but probably not. I feel like nobody has any attention in 2024, and social media doesn't help. So if you can't get it into a TikTok, it's probably not entering mass consciousness at this point, which I find like tremendously sad, which is part of the reason I do this. I know a lot of people are aware of, I call it like science communication. I think other people probably do too, but like, I'm trying not to like set you up with a bad question, but like,
try me.
Like, how do you feel about just the general lack of understanding of stuff? Because I feel like, especially like, we just got out of an election. The whole world seems, at least in America, other places I've been are not this way, but America very much is. Everything is so fucking polarized, and everybody's just looking to like score points on the other team. That's not how science works. That's not how data works. That's not really how the world works in its own way, but that's a whole nother conversation. So this is a really long way of asking, can we fix that? You know what I mean?
I sure hope so. I'm hopeful at some point we can.
Because it's like your whole field is incredibly difficult to try to explain to people, because you're looking at a point in time, like it rained today at 2:00, but you're also extrapolating that over hundreds of thousands of years potentially across. What does that pattern look like in this massive scale that most people probably can't fathom?
Yeah.
And then you're constantly in this, and I'm struggling to find an analogy with it, because I don't think most people encounter this in their normal life. It's like trying to focus, if you're playing baseball, it's like trying to focus on the ball coming in and then looking at somebody in the stands, and then somehow hitting a home run once in a while. Right. And anybody who knows anything about baseball knows if you take your eye off the ball, you're not doing well.
Sure.
Probably not hitting it at all. But that's the nature of the understanding. And then even in the baseball frame, we're in a stadium. Your stadium is like the planet. And I don't think people fathom how large the planet is.
Yeah.
Right?
How complex, yes.
You drive 20 minutes to work. It takes like, they're probably 36 hours to drive across the country at 80 miles an hour. Is there a way to bring people? I feel like we don't want to like exclude people, and that's how a lot of sciences were, either by the nature of it's just knowledge you don't have and you don't understand it. But I feel like when you bring people in at like the point in time of a study or in science, they latch onto it, and then all this other stuff happens, and then maybe that doesn't make a splash, or the media doesn't think it's cool enough to report. And so you have this out-of-date knowledge that persistently enters the populace.
Yes.
Am I making sense?
You are. Yeah, you are.
Yeah.
Science, especially climate science, has this disadvantage that it's difficult to comprehend.
Right.
In terms of like the basics, I guess, let me clarify. The basics are maybe easier to understand. The world is warming. Right. Carbon dioxide, CO2 acts like a blanket. The old analogy, the greenhouse effect. It's literally like a blanket that sits over the planet, traps heat, which is why our temperatures
and we
rise.
can measure the increase of that over time.
We can measure
too, right?
both the increase of CO2 and the increase of temperature. And what's more, we have a very strong understanding of why it happens. The physical, the physical understanding. We can model it dynamically. We can see how it develops. So it makes a lot of sense. But beyond that, the difficulty is explaining the sort of everything else around that, how it affects you.
Yeah.
And even I would say it starts with, unfortunately, the metric system. And what I mean is that climate studies are done using the metric system. We report temperatures in Celsius. We report rainfall in millimeters. We report wind speed in meters per second. The American public understands imperial units. We know Fahrenheit. We know inches. We know miles per hour.
A quick aside, America invented its own system, and us and I think New Zealand are the only ones who use it.
Yeah, Canada used to. They switched a long time ago. Yeah.
And then the English also have an imperial system, but it's different than ours because we're America and it has to be different.
So I think
that's a good point, because you don't even understand like the basic, like how do we measure is also a foreign concept.
Yeah, and if I could add something to that, because we report results in Celsius, it just so happens that the way the Celsius temperature scale works, the degrees are, each increment is smaller than Fahrenheit.
Right.
So 1 degree Celsius is like 1.9 or something degrees Fahrenheit, give or take. So when we talk about, for example, the 1.5 degrees Celsius threshold that was laid out in the Paris Agreement of 2015, how the world should try to keep global warming, or the rate of the overall change of global temperature compared to pre-industrial, to less than 1.5 degrees Celsius to avoid the most severe and disruptive impacts of climate change.
So it's like about 3 degrees Fahrenheit.
Yeah, it's about 2.7 degrees Fahrenheit. But the fact is that 1.5, that number seems really small to people, especially to Americans, I think. America is a land of big things.
Big, everything's big. Yeah.
Yeah, 1.5 just sounds inconsequential.
We're going to do climate change the biggest.
So I think a good start, if we just talk about Fahrenheit, I don't know if it's feasible or not, but yes, I think even to say to people, hey, 3 degrees is what the warming might be. And actually, we're way past that. We're committed
We've
to
blown it. Yeah.
We're talking about probably at least 5 degrees of Fahrenheit warming. And that's a more, I think, to a layperson, a more consequential number than 3 Celsius. 3 Celsius, 5 Fahrenheit. But then also what that means, that's a globally average temperature.
Right.
And
it could be 10 degrees warmer where I'm at, right?
It could
be 10 degrees colder where I'm at, right?
Yeah, an individual heat wave could be 10 degrees warmer.
Yeah.
An individual rainstorm could be 50% wetter with more flooding. But that's difficult to sort of draw a direct line from what that 3 or 5 degree warming will do to those extremes. Individual studies show that. But the average, Joe public doesn't know that. That's the difficult challenge.
The thing I've had a lot of success, because I've been a climate, well, not a climate person. I grew up outdoors, and I like outside, and I like the planet, and I'm really of the opinion that I guess Mars is cool now in the national sphere, but we can't understand how this planet works. To think that we're going to actually like survive on another planet that's so much more difficult and far away is like insane to me. But the data behind global warming to me is very clear. I don't even have a car because I understand it contributes, and I know that everyone can do that, and like there's a whole thing there. But the argument that I make a lot with people that seems to kind of start to break through is that, like you were saying, one, it's not 1.5 degrees, it's like 2 and some change.
2.7, yeah.
But also the difference between 32 degrees Fahrenheit and 35 degrees Fahrenheit is rain over ice or sleet.
That's a great analogy. Tipping points in the system, where a little difference makes a huge difference.
And 30 degrees means rain turns to ice probably. Mm-hmm. And same with heat, and heat's a little hard, but with like air conditioning, if you're in a part of the country where you have it, it's like everywhere now, seems like. Yes. But the difference between like 72 and 75 is like I'm kind of comfortable or feeling fine to like, oh, it's a little warm in here.
You feel it.
And yeah, okay, then I go turn on the air. But when the heat wave is outside, 100 degrees is really hot. 105 degrees is what I call fucking hot. But now you're adding maybe 3 degrees to that. 107, 109, that kills people.
Sure.
Right.
And your nights won't cool off as much too.
Exactly.
That also kills people when it stays hot all night.
Yeah. And so I think like it's starting to break through, but it's also so easy to attack because you can say it snowed today or it always snows, right? And I think the human mind, and I have this problem a lot with AI, like what AI can do and what the average public understands is like so far apart, it's actually terrifying me because they just don't know what's coming. They don't even know what's here. So I totally get it. I don't think we're going to solve it today, but I do like to just try to put that out there that the lack of appetite for complex things in this society has decreased dramatically. And I think that's frankly awful.
I agree.
And they're just trying to expose it. Right? I don't think I'll fix it, but a lot of people aren't even aware that, it used to, before TV, even people would sit around and read books, magazines, right? Family reading was normal.
Sure.
Now reading isn't normal, period. Like I read books because I'm weird, I guess, and I actually read paper books. And the amount of people I talk to say, oh yeah, I should do that. Or I should, I'm like, yeah, you just have to pick it up. It's never been easier.
Sure.
So
I read mostly on flights these days.
Yeah, I believe it. Well, and I love the book too because I'm on the screen all the time, so it gives me a nice like contrast of like getting off the screen and giving me like even a different environment, which is nice.
Sure.
I know we were talking a little bit about it before we started. I gotta bring it up because it actually makes me mad. But in the news, the president of the United States had to come out and say that the government doesn't control the weather and make hurricanes. I talked a little bit about this, I think, on the previous podcast with Anya, where we started talking a little bit about how algorithms are fucking up everything and how this idea that the government is somehow controlling the weather or created a hurricane to try to win the election is some lunatic conspiracy.
It's absurd.
That has now entered, but and a lot of people that I talk to will write it off because it is a conspiracy. It's crazy. But the fact that the president of the United States went in front of the world and had to say it or chose to say it, to me is absolutely terrifying. There is a history of weather experimentation. Cloud seeding, I think, actually dates back to like
the 50s, I think.
Well, I think even,
or before.
I've even read though that like China, when they were developing rocketry and gunpowder, 800 years ago.
Oh, you're going way back. Okay.
Had experimented with it, and whether or not it actually worked is, but potassium, was it potassium iodine that they shoot up, or I forget the chemicals, but the Middle East, there's a lot of, I don't know, I would call it like historical texts. I don't know if it's real or not, but people have been trying to control the weather for a long time. We want to make it rain when we need it. We want it to stop raining when we don't need it. And
sure.
And then, like you were saying, kind of in the 50s, I think was kind of the heyday of this. And,
yeah.
And can we talk maybe a little bit about like what's real. So like cloud seeding, the ability to like form clouds and make it rain, literally, is real, but it's also like it's not some precise thing we do, right? It's as you were saying earlier, this whole system is so dynamic and complex we can't understand it, but we can kind of fuck with it.
We can definitely
Right.
mess with it. Yes.
So, but like creating a hurricane is impossible, right? Like the amount of energy in these storms is like unfathomable to me.
Right.
To try to understand how much, would even take to make, right? I think a really interesting way to maybe put this is there's like effectively a hurricane on Jupiter that's the size of our planet.
Yes. The
Right.
big red spot, great red
Yes,
spot. Yeah.
you can actually see it from Earth, I think, with a telescope when the conditions are right. And the amount of energy to make that happen is like fantastic. So like, I don't know if there's really a question in there. It was kind of a statement of like, I can't believe this is happening, but I have a guy who can maybe talk through a little bit of like why it is or is impossible. But
I think, go ahead.
No, I'm just going to tail off.
Yeah. No, I think you're spot on. The amount of energy that a hurricane actually releases is enormous. Yeah. We do not have that kind of technology. I can say confidently, without knowing any of the secret programs the government is currently doing. I can confidently say we cannot control that. Think about, a hurricane is maybe 200 miles, 300 miles across. And a strong hurricane will have sustained winds of 150, 160 miles per hour, sustained for a day.
That's
or
twice
longer.
as fast as most people drive.
Right. So where do you get the energy to actually, if you're the government, where do you get the energy to power that or to even get that going to begin with? So that's, to me, completely ridiculous.
Maybe to use the analogy, I try to break stuff down when I can. It's like starting a bike in high gear. Right, you can like jump on the pedals, but if you're in the high enough gear, it's not turning. You don't have the amount of energy to even get the wheel to spin. So you either like find a hill or get a push or bring the gears down so that you can start easier, right? So to even start a hurricane, you probably need more energy than the hurricane itself has, which we still can't produce, right?
Sure.
And there are papers back in the 50s. We were talking a little bit about this, and I don't know a lot about it, but they were thinking about like, could we just nuke the thing? Because in the 50s, it was solving everybody's problem was nuking it.
Sure.
And I'm not even joking. Like some of the stuff that gets declassified is horrifying. They're like, we just we'll just fucking nuke that and we'll nuke that and a tornado will nuke it. And it's like, okay, it's a great tool, but maybe we shouldn't just use it for everything. But there was a lot of debate of whether or not it would even work to nuke the thing. The most powerful weapons humanity has ever created probably wouldn't take one out. So why would we think we could create it?
Right. And it's a good point. And the other thing is they talked, when I say they, is some of the conspiracy theorists out there. They talked about maybe the government steered these hurricanes. Yeah. They steered it into Florida, which is a red state. And same thing, to somehow change the trajectory of something so powerful and full of so much energy, where do you get the energy to actually move it off its path?
When we can't even predict where they go, really, right? You get
we have a cone of uncertainty.
Exactly.
We have an idea, but not the exact.
And with social media, this is the world we live in now, where all of these loose possible ideas come together to form this absolutely insane thing that, by the old definition of insane, meant that anybody with any sort of understanding of anything would have just said that's just
that's
out
ridiculous.
Of reality.
Right.
But now there's this credence, but this at the same time, I hear a lot of arguments from a lot of people who either believe this stuff or don't know any different. And I'm trying not to belittle people who disagree with me, but this is insane. The government can't do this. But they're the same people who will point out, well, it rained when they said it was going to be sunny. Right. But going back to, again, like how we kind of started, the amount of variability and constant change in this system is so massive that we can't even really understand how much is even there, let alone how to predict stuff. And that's where we get into stats, right? And these cones of uncertainty are just, as the data points become greater or the information becomes less, we have a less specific understanding of what may happen. I'm trying to describe stats without a picture, and it's really hard.
It's hard, yeah. And one way around that in terms of predicting weather is to basically run a bunch of simulations.
Yep.
It's called an ensemble, if you ever hear that term in the weather world. So you could take the same weather model and run it 50 times. And it'll give you different trajectories of how the weather might evolve in the next day or 2 days or 3 days. And, each different possible path has a different, what you would call, realization of how the atmosphere might evolve. Right? But if all 50, let's say you take all 50 and you're making a day 3 forecast, so a forecast for 3 days from now for a hurricane heading towards Florida. If all 50 possible realizations of reality from this model show the hurricane hitting within a 20-mile stretch of the coastline in Florida, you can say that's your cone of uncertainty.
Right.
It's going to happen with very high likelihood somewhere in that 20-mile stretch of the coastline. So that's as good as you can get these days.
And because it's statistics and because it's variable, there's also a chance where it's not as likely that it could totally miss. And this happens occasionally, right? Where the hurricane goes to Mexico or the hurricane goes to New York, right? We had that happen here a few years ago.
It's more rare these days. Credit to our research community and our forecasting community. Yeah, these forecasts for hurricanes are better than 5 years ago, 10 years ago.
It's hard to show that improvement because nobody's looking back to say, of the 100 hurricanes that we've looked at in the past however many years, these forecasts were accurate. These weren't. Everybody just remembers the miss, right? Or everybody remembers they said it was going to hit southern Florida and hit northern Florida.
The public, yes. Yeah, the public does not remember. Scientists can quantify 100%, this. They make charts that show, hey, over time, here's the past 10 years, here's the average forecast error. Look, it's going down. They can show you that. Yeah. But the public doesn't really see that as much.
Right. And I think for, again, people who aren't paying attention or if you're in Florida and you get hit by a hurricane you're not expecting, it's hard to then connect those dots. And then because the attention span of the country and even just everything is so short that you move on to the next thing. And then it's before you know it, hurricane season again. And then, oh, by the way, hurricane season's been increasing over time. And so the duration of the amount of hurricanes we get is longer, right? So this has been a fascinating conversation, man. I really appreciate you coming out and talking through. Is there anything else that you wanted to touch on or hit on that we didn't? Or I know we've kind of been a little bit all over the place, but I'd love to have you back on and talk about anything.
Yeah, thank you. It's been fun for sure. Yeah, if I can think of any closing to talk about, is that I just hope people, and you touched on this too, people take a little more time to try to understand sort of these things, It's tempting, we have a very fast-paced media culture these days with social media. We have news coming at us 24/7 from all angles. But it'd be great if people, maybe paused a little more to think about why some of these things that climate scientists say might actually make sense or be true. I feel like we're missing a little bit of that sometimes.
And I would say science isn't perfect and no field is perfect either, but at scale with hundreds or thousands of people working on stuff, the ideas that are coming forward, I think are probably the right ideas. And it's the right conclusions.
Yes, in aggregate, yes.
And stuff can change. And there's been history, of science where eugenics comes up sometimes, and biology is where my life has been mostly. And yeah, it was a period of, I don't know, well, it's still going on depending on who you ask, but it's probably, 15, 20 years where people thought that eugenics was just this brilliant new discovery of biology. But then evidence came out and it went away.
Sure.
And so for a point in time, and that's, I think, a great kind of analogy of what we've been talking about. So people, I guess this is my really poor way of trying to challenge people to also look at time horizon in everything we do. We just had an election. All I'm hearing is all sorts of crazy shit about how the world will either end or it'll be the greatest possible. Believe it or not, the country's been here for a long time and there's been crazier shit that's happened and it's made it. And most people probably don't even remember it. We had a civil war in this country, right? But it's really hard for me, and this is going to be my new mission, is to try to break this down in a way that's more easily understandable. Because I think even time horizon is a kind of a concept that a lot of people probably have no idea.
Yeah.
Hopefully you can Google it. I don't know. I don't actually know. You can, because it is a thing that people do talk about. But like,
it's true. Yeah. People don't remember a lot of things beyond a year or 2 years ago. It's not as meaningful to their daily lives.
And I need to have a psychologist on, because like this was studied a long time ago. And the easiest way, I think, to try to put this down is every time you hit a red light, you think you only hit red lights, right? You don't remember the green lights you hit. You don't remember the yellow lights, because the red light typically stops your progress on something or interferes with a thing you're trying to get home. You're trying to get to the show. You're trying to do, get your kid from practice, and it's preventing you. So you have this kind of like anger moment, and the anger moment is much more visceral than the positive moment of you just cruise on through the green light and it's uneventful. And hopefully folks at home are like not sleeping and are like, this guy keeps rambling today, what the hell's going on? But it's such a hard concept to break through that I really want to, I think, to really understand like climate versus weather versus how this all works, is you really have to think through the time horizon thing.
You do.
Because you have to look at a moment in time, but then also have that in context. And I think the closest field probably after that is probably like history, right? The one battle in the war probably didn't make a huge difference in the whole totality. It's like, I got really wet today on my way to work. It's raining harder than it ever has. Well, today maybe it was the hardest rain we've had in a year or 10 years or ever, but that doesn't mean, that it's raining harder every time.
Right. Exactly.
I don't know. Hopefully that made sense.
It makes sense. Yeah.
I do like to ask people too, it's kind of a closing question of, is there anything that you're reading or watching or consuming that you want to share with folks? It can be related to this. It could be something totally random.
Yeah, I actually tend to read a lot of sort of self-improvement books.
Okay.
I find it a nice sort of break from my daily climate and weather world.
Yeah.
So one book I recently read, actually the most recent book I read, was called The Happiness Trap. And I do not remember the author. I should have remembered the author's name. Yeah. But yeah, the book is called The Happiness Trap.
Okay.
And it basically is written by a counselor, psychotherapist, who talks a lot about how, as the name suggests, we shouldn't shoot for happiness as the ultimate ideal.
Sure.
In terms of everything has to be happy. We really should learn to process all of our emotions, including the unhappy ones, the unpleasant ones. Make room for them in your mind, acknowledge them, and sort of, learn to build your day and live your life despite negativity around you. Not to say you should, be passive in the face of negativity, but it's more about processing your emotions. Because if you set unrealistic goals of always being happy, always striving for things to work out well, in life, things don't work out well. You'll be disappointed a lot. So I thought that was a nice reframing of things.
No, I love that. It's like, I only want to hit green lights.
Right. You can't always hit green lights. Make room in your mind for red lights.
No, and I'm trying to combat toxic positivity too, that especially working in tech, it's like you have to only look at the positive in everything, and you can only be happy about stuff. And it's like, well, no.
That's a good tie-in. It's a real thing. Yeah.
Yeah, you can absolutely have a dismal look on something, but then still improve, right? If you're losing the game and you're like, we're winning, you're not going to win. But if you're losing the game and you're like, oh shit, we're losing, we need to now do something different. Or it's understanding and recognizing that emotion is an indication that you probably need to do something different or else.
Yes.
Even if you're really happy, that's great. Everybody, I think, hopefully likes being happy. But if you're happy all the time, maybe you're not in touch enough with reality.
That's a good point. There's maybe some self-reflection missing.
Yeah, and everything, it's a spectrum. It's a roller coaster. It's all this stuff. But I love that. I'll have to check that out, and I'll put it in the show notes for folks to take a look at too. But yeah, I appreciate you coming out. Appreciate you sharing.
Thanks very much for having me.
You can find us at 38.com. It's like the word create, but with a 3 instead of the C. As always, we encourage you to listen, watch, do. We'll see you next time. You can support this podcast at patreon.com/38 or at ko-fi.com/38. Thanks for listening.